Hello students, welcome back to Fun Scholar. So today we are going to start a brand new chapter, Work and Energy. This particular chapter is from the syllabus of ICSE class 8. So we are today discussing the chapter Work and Energy of syllabus ICSE class 8. So you might have read about this chapter in your previous classes in standard 6 or 7th. You might have a small idea of how work is defined, because in the ICSE curriculum there is the notion of work, there is the notion of energy in the preceding classes like 7 also. But now what we are today going to do is we'll try to investigate further and in depth into the description of work. How do we define work? What are the properties of work? The numericals associated with the work, and what is energy? We generally use these words in our daily life, but what is the significance of these words? How do we use them? What is the scientific definition of these words? Now, once we understood the definition, it is important to understand the different forms and its applications in the real life scenario. Then we'll delve into the numerical section, where we will practice a lot of categories of the numericals for both work and energy. Okay? So let's start the discussion, and meanwhile, while we will go through this chapter and the presentation, you will get to know each and every topic in detail. So let's start. Work and energy. Now it is a very common term that we use in our daily life that, Mom, I have done so work today that I am tired. Dad, I have feeling so much tired because I have done a great deal of work today. But we have to investigate whether that use of word is applicable in the definition of science. So we'll try to investigate. The meaning of work in the daily life and in the field of science is quite different. Now suppose I am sitting in a particular posture for around 1 hour, 2 hours, continuously reading a book, continuously trying to get through a topic, and I'm not changing anything. I'm just dedicated to that chapter. But I'm not changing even my posture. That's how my dedication is. So in real world, we might say that I am doing a great deal of work. But if my posture is not changing, which means the position is not changing, and if there is not a concept of force in that particular definition of work, then we will not call that thing work in the physics. For defining physics in science, we need two things that we are going to discuss. Okay? So that is the idea. Suppose what I was trying to say is, this guy is standing, sitting, someone is riding a bicycle. So there are various types of personalities in this particular slide, and they are doing different types of work. Work which is used in the language of English, word which is used in their daily life. But we have to categorize whether the man standing here, the man sitting here, the man riding the bicycle, the man who is using the lawnmower, and the one who is taking up the basket, whether all of these are doing work or not. This is where the definition of works becomes very handy and important in the science, in the field of physics. Okay, so as per our definition of science, as per our definition of physics, we'll say this person who is sitting and reading a book will not be doing a work, because he is not changing the position. His posture is very steady. It is not even changing, having a glitch, nothing else. The man standing just beside you might not be able to see, but there's a person who is standing just beside the person who is sitting. Is a man standing here. So if this person who is standing here, I'm not talking about this one, this is the one who is riding the bicycle, but if you are standing here for 2 hours, 3 hours, 4 hours stretch, then even if you have performed a very physical exhaustion, by the definition of physics, you have not performed any sort of work. So what is work in the definition of physics? That exactly is the topic of this particular chapter. How do we define work scientifically? What is the scientific definition of work? So in physics, if we have to define work, in science, when we have to define work, we need two factors, two physical quantities. The first is force. The second one is displacement. So force and displacement has to be there somewhere involved if we have to define work. Let's see how. So suppose there is this box, and this box is being pushed by this person. Now pushing or pulling is called force. So when the guy or the person is pushing the box, we can say that force is being applied. We can definitely say a force is being applied because the box is getting pushed. Now, upon pushing, we are assuming that this particular box has changed its position. It has moved from this initial position A to the final position B. So there is a shift in the position of the box. It means that there has been a displacement as well. And what is the cause of displacement? This particular force. So we can also say that because of the pushing of the box, the force was applied, and because of the force was applied, there is a displacement as well. There is a displacement as well. So in science, in physics, dear students, when we define work, we say that work is said to be done when a force applied on any object produces displacement in the direction of the force. If you have pushed the object, then you have applied the force, click one tick in the force section, then that force has caused the displacement. Let me give you an example. Suppose I have taken this object was here, now I have applied a force, I have pushed it and it is changing the position. So there is force, there is displacement, and that is why we can say the work is being done here. So you can see the theoretical definition is when force applied on any object produces a displacement, it is called work, or work is said to be done when a force applied on an object produces a displacement in the direction of the force. Any of these could be found in your respective books. What will be the formula? The formula is designated here as work is equals to force into displacement. Okay? Now you know that the SI unit of force is Newton. So we will be saying, sir, I can tell the SI unit. It will be Newton. For displacement, it is meter. So it has to be Newton meter. But again, there is a concept that the name of this unit, the SI unit of this quantity, physical work or work, is given after the name of the scientist. So this has been given the term joule. So the SI unit is joule. If joule is not given, we can write down Newton meter, but that would be a kind of a rare case because whenever the SI unit of work is asked, it is going to be joule. So you will always write the SI unit of work is equals to joule, and the symbol will be in capital because it is named after the scientist James Prescott Joule. Okay. So what is the relation now between 1 joule and 1 Newton meter? So it is said that when a force of 1 Newton produces a displacement of 1 meter, we have to relate this now. So the question might come, the SI unit of work is joule, but how will you define joule? What is 1 joule? So we'll say 1 joule is the amount of work done when 1 Newton of force produces a displacement of 1 meter. And that is how we define joule. So I will be writing the definition. So for now, the SI unit is what? The SI unit is joule. What is the CGS unit? CGS unit is ERG, erg. And what is the relationship between the SI unit and the CGS unit? The relationship is this: 1 joule is equals to 10 to the power 7 ERG. This is the SI unit. This is the CGS unit. So to revise this, what is work? When we apply a force and that force produces a type of displacement or a displacement in that object, we call that work has been done. What is the SI unit? SI unit is joule. Symbol is capital J. What is 1 joule? 1 joule is 1 Newton of force causing 1 meter of displacement. Is it scalar or vector? Dear student, keep in mind this work is a scalar quantity. So you will write down work is a scalar quantity. What is scalar quantity? A scalar quantity is a quantity which is only dependent on the magnitude. It doesn't require direction. It only requires the magnitude for its expression. So you will write down requires only magnitude, and not direction. So I hope the definition and the distinction of work in the real life, in the literature English and in the world of science are quite different, and I hope by this description it is very clear also. We cannot say the work done like sitting, like sleeping, like taking a high amount of mental work. Doing a high amount of mental work does not mean that you are also doing actual work in the definition of science, in the definition of physics. For work has to be done, there has to be a force, there has to be a displacement because of that force. Okay. So in the simple example, I will again give you the definition. Suppose this is a box and you have applied a force. So the first is force, whether the force is applied or not. Yes, if the force is strong enough to cause a displacement, if the force is strong enough to cause a displacement can either be represented through D or S. So it totally depends upon the book you are using, but preferentially we can take S, because from now on you will always represent length using S. So do not confuse S with the speed. So right now we are saying the force is there, the displacement is there, only then we can say yes, work is present. So that is the idea of work. Second most important thing, how do we define 1 joule of work? So write down, you can write down it as 1 joule of work is said to be done. 1 joule of work is said to be done when a force of 1 Newton produces displacement of 1 meter. That is 1 joule is equals to 1 Newton into 1 meter, that is equals to 1 joule Newton meter. So you can write it down. What is 1 joule of work? When 1 Newton force produces a 1 meter displacement, that is equivalent to 1 joule. So this is the definition. You can write it down. So write it down. I will give you a minute of time and then we'll proceed further. So it is that easy, and it is very interesting to understand the difference when we are talking about the work that we use in our daily life and the word work when we are using physics or when we are using science. It is completely different, but it is important to understand. Now, moving ahead, let's try to understand one thing. We have to always understand that work, it is a very important line, so you can write it down. Work is calculated based on agent who is applying force. So always ask work done by whom? Work done by whom or which agent if multiple source of forces are there. Now don't get confused. I will give you a simple example. So if there are many instances when there is no single body that is applying force. Suppose I am pushing this remote control. So because of my force, this remote control is getting pushed towards that direction. But at the same time, there is a force gravity that is also acting on every object. So while I am pushing that object, gravity is also acting down. So the question is, you will ask every time, sir, I have to calculate work. I got it. But tell me which agent is causing that force. So you will ask, should I calculate work done by human or should I calculate the work done by earth? This should be the question, and that is going to be more clear when we get to the question. So for now, just remember this thing, take a screenshot. This is very important. So it is always dependent upon work done by whom? By human, by gravity, by friction, by whom? You have to ask the question because it makes it very simpler to calculate the answer. Okay? Let's solve the basic question. When Amit was driving the car, it suddenly broke down. He starts pushing it with 200 Newton force, which causes the car to move 2 meters. So first of all, identify what is the agent of force. So here, Amit is pushing the car. So who is applying the force? Amit. Because of that force, the car has moved through 2 meters. So you have already got two quantities. So write it down. Force is equals to 200 Newton, and the next thing is displacement. So you can use S or D, that is 2 meters. The question is, what is the work done by him? Now the question is already given that you have to calculate the work done by Amit. So you don't have to confuse, should I calculate regarding the gravity or anything in the world? It has mentioned that you have to calculate the work done by Amit. So force applied by Amit is this much. This force has caused a displacement of 2 meters. What was the formula of work done? Work done was force into displacement, or you can write force into displacement. So just put the formula there, students. It is going to be work is equals to F into S, that is going to be 200 into 2, that is going to be 400. The SI unit is joule. So let us check. This is not going to be the answer. This is not going to be the answer. This is the answer. This is also not going to be the answer. So the final answer from our perspective should be option C, 400 joules. Simple. 200 Newton into 2 meters, 400 Newton meter. Now Newton meter can be written as joule. So we can also say that this could also be rewritten as 400 Newton meter. This could be written as 400 into 1 Newton meter. Now we can substitute this 1 Newton meter with 1 joule, making the answer 400 joule. So I have given you both the processes. Once you are comfortable with this step, you can directly use this one. And this is the most easier one to get to the answer. So here the work done by Amit while pushing the car which has moved through 2 meter because of the application of 200 Newton force is 400 joule. Let's check our answer. So the answer is 400 joule. Okay, we have done it correctly. Now let's try to see the next question. Now Amit now reaches the garage and he has to take the toolbox from the garage to the car. Now the car is being pushed till the garage. Now he is taking up the toolbox towards the car because he wants to do some changes. He wants to do some checking. So he is pushing the toolbox. He does it by applying a force of 100 Newton. So who is applying the force? Amit. On what he is now applying the force? What is the body on which he is applying the force? Is it the car or the toolbox? You are very clear. You are very intelligent. You are saying it's a toolbox. Now, this force 100 Newton has caused the work done on the box. Now, instead of displacement, here we have been given the work done. What is work done? It is 1 kilojoule. We have been asked to calculate displacement. So here we have been given force, that is 100 Newton. Displacement, is it given? No, that is something we have to find it out. And the work done we have been given as 1 kilojoule. So first of all, you have to convert this into SI unit. It is not joule, it is 1 kilojoule. So for the prefix kilo, we multiply it by 1000. So it is going to be 1000 joules. Now out of three quantities, work, displacement and force, we have two. So we can easily find out the third. Now work done is equals to force into displacement. Therefore, displacement will be equals to work done by force. Okay. Now just substitute the formula. So what I am doing is, I am doing here So displacement is equals to work done by force. Work done is how much? 1000 joule. That is going to be 1000 divided by the force is 100 Newton. That is going to be 10 meter. Now you can try to do it in reverse also and find out the answer. So if you multiply 10 with 100, you will get 1000, and that is the work done given. So for us, the answer is going to be 10 meters. Let's check it out. Option B, it is 10. You can also cross check. How? You just have to substitute the value. Work is equals to force into displacement. Force is 100 Newton. Displacement we have found is 10 meter. That is going to be 1000 Newton meter. Now Newton meter can be substituted by joule, and 1000 joule can be written as 1 kilojoule, which was initially given. So our process, our answer are exactly correct. Is it clear, students? Very good. Now let's try to interpret this situation. We have understood what is work. We have solved the solutions. We have solved a work upon numericals. We have tried to solve 2 questions till now. And let's try to give it a theoretical and application based analogy. So what is the scenario? 4 cases are there. Someone is cycling uphill. Someone is working on the PC. Someone is pushing the cart, someone is reading a book. We have to say in which of the following cases work can be considered to be done. Now, for work we need 2 things, the force and displacement should be in the direction of force. This term is very important. The displacement produced should be in the direction of applied force. So, in the first scenario, someone is cycling uphill. He has to ride the bicycle. He is pedaling, so he is applying a force. And because of that force, so force is there. And because of the force, there is a displacement produced in the car, in the position of the rider. So there is also a displacement. So force is there, displacement is there. So yes, work is also present. Clear? Let's take this example where we are talking about the scenario working on a PC. Now you are sitting on a table continuously doing the paperwork, you are preparing a project, you are preparing the assignment that you have been assigned to from the teachers. Now you might say, sir, my finger is continuously tapping the keyboard. It is obviously moving. So we are assuming that we are considering the body as whole. We are not just considering a part of the body, the fingers which are moving. We are talking about is this person, is this human being is performing the work or not. So overall, if you see, he is tapping, so he is definitely applying the force, but because of the force, is the body is moving anywhere? There is a shift in any body? So you will say no. So it means that the body has not displaced. So you will say, sir, force is there, because you have to mention now he is tapping the keyboard. But there is no displacement in the overall body. So there is no displacement, and hence the work done is 0. So there is no work done. So in first case, let us call this case A. There is case of work done. Call this case B. There is no work done. Similarly, pushing a cart. Now we are assuming, I am giving you the assumptions also so that you might not get confused. He is holding the cart. He is pushing the cart, so there is application of force. Now we are saying that because of that push, the cart is moving. I have given you the assumption also. So you might not feel any other scenario that might make you answer differently. I am saying here the force is there, and because of the force, the body is getting displaced. So displacement is also there. So work is done. Only criteria, force is applied. And because of that force, the body is getting displaced. Yes, it is a scenario of work done. Therefore, work is performed. What is the next scenario? Reading a book. So again, you might be thinking we are flipping the pages. No, we are considering a case where I am just sitting and very deeply into the book. because the book has a brilliant chapter, work, power and energy, which is being taught. So I'm so engrossed in it, I am so involved in this chapter that I am not flinching even my hands. The book is strictly at the position in which it was initially. So yes, because of my hand, there is a force on the book. But is the book moving? I am saying no. Now tell me, is the work done here or not? So I am saying force is there because somehow we have to apply the force to hold the book. But is the book moving because of that force? I am saying it is unmoved. So the displacement is absent. If the displacement is absent, we can say the work is also zero. So the work done will be absent. So here in case A, B, C and D, case A and C shows that work is getting done, and case B and D represent that there is absence of work, which means that there is no work done in case B and D, while there is a work done in case of A and C, which again help us to revise. Work is said to be done only when the force applied on the object produces a displacement in the direction of force. Okay, dear students, let's move ahead. Now, what could be the scenario we are considering when the work is going to be zero? We have quite seen till now the various scenarios where the work done is zero. But talking about point wise, let us consider what are the cases where work is going to be zero. We have said work requires two quantities, force and displacement. What if there is no force at all? There is no question of work because you have not applied the basic thing that needs to be applied for an object to move, that is force. So if the force is zero, there is no concept of work. So suppose this block of 5 kg is sitting or resting somewhere, but there is no force which has been applied on this block. In this particular block, the force is zero, so obviously work will be zero as well. So the first scenario of zero work done is zero force applied or no force applied. What is the second case? I am pushing hard this wall, I am pushing hard this panel, but this panel will not move. Despite of giving the force, if there is displacement is absent, then the work done will be zero. So here the force is there, but the displacement is absent. It is zero. So the work done will always be zero. So it means that either the force has to be zero or the displacement has to be zero. See this particular scenario also. Now this is something that I am trying to discuss. Okay. Now take this example. Okay. I will try to talk about first thing where S is equals to 0 and there are two cases. The object didn't move at all. And the second case is net displacement is, let's keep this for a while. I am discussing a different scenario where S is 0 but the reason is different. Net displacement is 0. What does it mean? Suppose, again, this remote control becomes very handy. It helps us to understand work. So this is the initial position of the remote control. Let's say at point A, this object was initially present and I have applied a force on this. Because of this, it has moved through a distance d and it reached the point B. So now, if I am talking about the motion of the object from A to B, the work will be force into this displacement, let's call it S or D, whatever. But this scenario is now changed. I am saying that my assumption is the object has gone through this distance, it has reached from A to B and again come back to the initial position B to A. So it has gone there and come back to initial position. Now displacement says, displacement is displacement is the shortest distance between initial and final position. So whatever the final position is, we'll subtract the initial position from the final position. That is displacement. But in the case of round trip, when I'm putting this from A to B and bringing it back from B to A, the final position and the initial position is getting same. So here it will be I minus I, that is 0. So if an object moves but it comes back finally to the initial position, the net displacement is 0. In that case as well, work done will be 0. Don't worry, we'll try to solve some questions that will help you as well, but this is very important to understand. Displacement doesn't mean that it doesn't need to move. It also means that if displacement is 0, it has moved through a distance and come back finally to the initial position, and that is why the final and initial position are same, and that is why the work done is 0, because displacement is 0. The third case is the force is perpendicular to the displacement. Now consider this case. Now suppose someone is applying a force. I am applying a force on this table, and this table has moved through a distance d. So I will say the work done is F into d, but there is a glitch. You have to ask, sir, work done by whom? Very good. So you will say, sir, work done by sir will be force into displacement. Next question will be, if someone asks, what is the work done by gravity? What is the work done by gravity? Now, the question will arise, the block is moving. This particular desk is moving through this distance. But is it moving through that distance because of gravity? So we'll say no, it is moving because of the force by sir. So where is the direction of gravity? Gravity is acting downwards. This is the force of gravity. Displacement is happening this direction. Are they perpendicular? So we'll say yes. So they are looking perpendicular. It means the angle between force of gravity and the displacement is 90 degree. So we will say work done by gravity is 0, since work done by gravity is perpendicular to displacement. That is why in the definition we have defined work as, and work is said to be done when an object on which the force is applied produces a displacement, and the displacement is in the direction of the force. So displacement has to be there, but it has to be in the direction of force. If the force and the displacement are perpendicular, the work done is going to be 0. So this is the situation, dear students. We have discussed the cases where work is going to be 0. So to kind of assimilate entire thing, try to go through this exercise video that will help you to enhance your understanding. Try to understand this.
What do we know about the concept of work? Is there just one meaning for work? Let's find out. A boy has done certain activities like washing the dishes, writing a letter to someone, and brushing his teeth. Are the boy's following activities considered as work? If your answer is yes, then you are right and wrong. You are probably wondering, how could you be right and wrong at the same time? Well, let's see why. You are right because the general concept of work could apply to any sort of activity that requires energy. But in the scientific perspective, it is known to be zero amount of work. So what is considered as work in the scientific perspective? Let's try out an example to understand this. An evil monster wants to destroy a city, but he doesn't go straight to the city to destroy it. Instead, he takes a huge boulder next to him, aims it at a specific direction, and throws it, destroying a part of the city. Is the activity done by the monster considered as work in scientific terms? If your answer is yes, you are right. Granted, it was a bad kind of work, but it was work nonetheless. aspects done to consider this as work? Why did I say that work's done here? There are two requirements that should be met for work to be done. One, force needs to be applied on the object. Two, the object needs to be displaced. If an object does not meet these two conditions together, then it isn't considered as work. When the monster threw the boulder at the city, he applied force on it and threw it in a specific direction and hence displaced it.
So whenever we are trying to define work, there has to be notion of force, there has to be a force, there has to be a displacement. And we have already discussed about the cases where work done could be zero, either the force is zero or the displacement is zero. Now displacement could be zero in two ways, either the object didn't move at all, or if it has moved, it has gone through a distance and come back to the initial position. So the final and initial is same, and that is why displacement is zero. And the third case is the direction of force and the direction of displacement are perpendicular. So there is a 90-degree between the force applied. So there is this displacement, there is this force. They are forming a perpendicular 90-degree angle between them, and that is why work done is zero. Now let's try to apply some of more understanding towards this video, which has some theoretical questionings also. Try to go through this and try to ask the good questions and answer them, and it will create a confidence in
There
you.
are two requirements that should be met for work to be done. One, force needs to be applied on the object. Two, the object needs to be displaced. Now let's say a constant force is applied on an object and the object is displaced through a distance s in the direction of the force. Understand what I said? The work is done on an object through a force which is constant. What does that mean? To put it in simple words, force applied doesn't change its magnitude or its direction, and the object is displaced in the direction of the force. Now, how can we make this into a formula? It's very simple. Work done is the product of force and displacement. It equals F, which is the constant force, times S, which is the displacement in the direction of the force. So W equals F times S. Thus, the magnitude of the force multiplied by the distance moved in the direction of the force is equal to work done by that force acting on an object. Remember, work has only magnitude and no direction. Let's try an exercise to get a clear understanding of this concept. A cat sits on a table. He notices a remote control there. Like all feline creatures, it tries to push the remote control to a certain distance and is satisfied after doing the deed.
Now let's get through this situation also. The cat applied the force on the remote control, so there is an application of force. Because of that force, the remote control got displaced. So if I ask you, is there any work done? You will say the work done requires two things: the force which is being applied by the cat. Is the displacement is because of the force? Yes. So there is force, there is displacement, so yes, there is a work done by cat. So we are trying to implement what we have understand. Now see this video. I will be present here also to make you understand to the confusion portions.
Let's see where our problem solving comes into this. Let's say the cat applied 10 Newton of force on the remote control and the displacement is 1 meter in the direction of the force. What is the work done by the cat in this case?
Now we have solved this question. I know that you might have solved by now also. The force is there, 10 Newton, the displacement is there, 1 meter. So it is F times S, 10 Newton into 1 meter. It has to be 10 joules. So let's see whether we have found it correctly or not.
Since the force acts on the object through displacement, we multiply the value of the force with the value of displacement. So multiply 10 with 1 and we get 10 Newton meters as the answer. So is the answer complete here?
Now we know that 10 Newton meter, we can substitute this 10 Newton meter. This will be further shown in the video, but for now, to avoid your confusion, we can write down this 10 into 1 Newton meter, and this could be substituted with 1 joule. The final answer is going to be 10 joule. So this is going to be shown here, but I have also provided you the answer beforehand so that there is no confusion. So let's complete the video.
Not exactly. The SI unit of work is Newton meter or joule. How can we define joule then? 1 joule is the same as the work done by 1 Newton of force that displaces the object by 1 meter. So from our current exercise, when we get an answer of 10 Newton meters, we can also say that the force applied is 10 joules.
So that is the idea. You can write 10 Newton meter, but Newton meter is not the SI unit. It has to be joules. So we have defined how 1 joule is related with 1 Newton meter. 1 Newton of force producing 1 meter of displacement, and that exactly is 1 joule of work done. So we can substitute 1 Newton meter with 1 joule of work. And that is how this question has been designed and solved in front of you. Now let's see the another question.
Here's another exercise for you.
Now try to go through the question. Whenever you see the question now, try to read it first, mark or underline the things that are very important for us. So let me give you an example. A man applied a 20 Newton force. So the value of the force is given and I have underlined it. On the ball with a displacement of 3 meter in the direction of the force. So it is clearly said that there is a ball on which there is a force is applied, and because of this force there is a displacement. Now I know the value of the force is 20 Newton, the value of the displacement is 3 meter. The question is, what is the work done by the men? So we have also been given the agent by which the work is done. Work done by men. Work done by men will be equals to force done by men and the displacement because of that force. So I'm just writing F into S. Now this is going to be 20 Newton and that is going to be 3 meter. The answer is going to be 60 Newton meter, which could be eventually written as 60 joules. So let's try to see whether we have discussed it correctly or not.
With the force acting on the ball through displacement, we multiply 20 Newton of force with 3 meters of displacement to get 60 Newton meter or 60 joules as the answer. Now, if the object is displaced and exerted with force in the same direction, the work done by the force is considered positive. When is work considered negative then?
Now negative is something that is not included in your syllabus, but it will also create confusion. So I have not discussed the negative work done, but we have considered the positive work done, which means that work done have a positive value, plus 60, plus 10, plus 1, plus 2, anything that is positive number. And we have also discussed when work done is going to be 0. Work done is going to be 0 when F is 0, when S is 0, when the initial and final positions are same, and also when the direction between force and the displacement is perpendicular. So these are the cases where we have defined and understood work in the terms of question, in the form of video, in the form of PPT. Now let's just try to understand one more time, revision one more time through a simulation. So try to see this, how work is going to be defined. So there is a force and that force is moving the object. The object is getting moved towards the direction of the force. So there is force and displacement, force into displacement. That is how work is defined. So this is a simulation. See it again. So there is a force and look at the definition here. We have already discussed this all. The idea is to have you understand it in any way that you are comfortable with it and revise it as many as times as possible, so that once you start to solve the questions, once you start to answering the questions that have been thrown at to you, you are very confident. I have understood this chapter, I have understood this topic, I can answer all it correctly. Okay, now moving ahead, let's move to the next part of the PPT. So this is something that we have discussed. Let's try to solve few more questions. So I'm giving you the question, I will be solving along with you, but I want you to solve it first. So I will be giving you the question, you can pause it, you can take a screenshot, you can also take it once I have solved the question, but try to solve it from your side first. So the force is of 20 Newton, the displacement produced is, let's say, 2 meters. What is the work done? Now it is very easy, we have discussed it many times. So that is going to be force into displacement, 20 Newton into 2 meters, that is going to be 40 joules. Very clear, very simple question. Now we have been given that the work done is 100 joule. We have been given that displacement is, let's say, 2 centimeter or 2 meter. First I want you to solve this one. Displacement is 2 meter, calculate the force. So out of 3 quantities, we have been given 2 quantities. So what you will do? You will write the formula, work is equals to force into displacement. So here we have been given 100 joule is equals to force that we need to find out, and this is 2 meter. Force will be equals to 100 joule divided by 2 meter, that is going to be 50 Newton. Why? Because if you want to understand this, 100 joule by 2 meter could be written as 100 Newton meter divided by 2 meter. Meter got cancelled, we got 50. So you don't even to bother that how Newton came, it is very obvious. So these are the 2 categories, very simple ones. Okay, now let me give you another question. So this time the question says that the displacement produced is 5 centimeter, the force is, let's say, 0.1 Newton, calculate the work done. Now you might be saying F into S, that is going to be 0.5 joule, but there the answer will get wrong. So you have to first see the SI units. So here displacement is given as 5 centimeter, the SI unit is meter, so we have to convert it into meters. That is going to be 0.05 meters. What is the force? Force is obviously in the SI unit, so it is 0.1 Newton. Work done is going to be force into displacement, that is going to be 0.1 into 0.05, that is going to be 0.005 joules, or in the fractional form 5 divided by 1000 joules. So there are not going to be difficult questions, there are only going to be a tricky changes. The tricky changes refers to the change in unit. It might be given into SI unit, it might not be given into SI unit. So you have to be very careful what unit you are using. The another change is that out of 3 quantities, 2 will be given. You have to just rearrange and substitute it correctly. Once you understand the concept, there is no way that you are going to get it wrong if you had understood it. Okay, so these are the questions that we can easily solve. Now solve this question. Identify the component of work that is 0. So these are the 3 cases. The first case is, again I am giving you the assumption so that you might not get confused. A person is pushing the cart is getting pushed, so the force is there, but my assumption is the force is small enough, we are just touching it, just giving it a gentle push, so there is no displacement. So here the force is there, and I am also assuming that the displacement is 0, the cart has not moved. If you consider that, then displacement is 0. So yes, force is not non-zero, it is non-zero, but it is 0. And if I assume the force is there and displacement is there, both are going to be non-zero. But my assumption is no movement. So based on this, you can solve this question. Next question. The second category, you have taken up a ball and you have thrown it up. So you have pushed the ball has gone up and it has came down to your hand finally. So if I ask you a question, simple question, first tell me the work done of this part. This is part A, where you have just thrown the ball. So there is force, and because of the force, there is a displacement. So I am talking about that case. You have applied the force, the ball has gone up. There is force, there is displacement, so there is work done. Okay. Now here I am talking about the next scenario where you have thrown the ball has gone there and again came back to your hand. So I am saying that the ball went up and came back to the initial position. In this particular case, yes, there was a force. Yes, the ball did move, but the initial and final positions are same. So here the displacement, the net displacement is 0. So that is going to be the answer. Now again I have assumed two cases. First, I have not considered coming down of the ball. Second, I have considered the ball has gone up and came back to the initial position. Now this practice will help you to understand the many cases, many applications where you can provide an answer to the work done. Third case, you are pushing the ball, but the ball is not going to move because no matter how mighty you are, ball has much higher strength. So you are pushing the ball, but the ball is not moving. So the force might be non-zero, but there will be zero displacement. So these are the cases that we have revised, that we have solved, that we have discussed to help you understand better the concept of work. What is the next thing? Now, okay, solve this question. This is very important question. Now, if you have understood this entire discussion of 45 minutes, 50 minutes very well, then you are able to answer this question. So I will give you some time to think about this and try to solve the question. What is the question? Is there any work done on the aeroplane by Earth's gravity? Now, wait a second. There is a glitch here. So we will go back to our panel. So the question is, what is the work done by gravity? You have been clearly mentioned. You have to calculate the work done. Work done not by the plane itself, work done by gravity. Do nothing. Just try to find out the force, the displacement. So we are saying that there are many forces. The machine of the aeroplane will be pushing it forward because the gases will be getting exhausted from the backside. There is a Newton's third law. It will be moved forward. We are not talking about that work done. We are talking about the plane is moving in this direction. This is the displacement. The displacement is this, and the gravity is always working downwards. The force of gravity is always working downwards. So this is the force of gravity. Now, because of gravity, we have been asked to find out the work done. Can you get a glimpse of our discussion? If I say, what is the angle between the gravitational force and the displacement? You will say 90 degree. It means that angle is 90 degree. It also means that force of gravity is perpendicular to displacement, and when this scenario happens, the work done is zero. So we'll say work done is zero, but by whom? Work done by zero, by gravity, and that was the question. So here the work done is going to be zero or no work is going to be done. So what will be the answer? Yes or no? Is there any work done on the aeroplane by Earth's gravity? The answer is going to be no. So dear students, we have discussed all the possible questions, all the possible cases where you need to find out the question based on work. From the next session, in the next class, we'll be starting the topic of energy. What is energy? How we define energy? What are the different forms of energy? You might have heard about kinetic, potential, mechanical. All those energies will be discussed, and the numericals also will be getting discussed. So see you in the next class, fun scholar. Thank you.